Finally, in Chapter 6, we're going to look at trapezoids and kites. These are the last two types of quadrilaterals that we're going to deal with. So we're first going to deal with the properties of trapezoids, and then we're going to look at properties of kites. So first off, what is a trapezoid? A trapezoid we are going to classify as a quadrilateral with exactly one pair of parallel sides. Remember, a parallelogram had two pairs of parallel sides. Now a trapezoid we're saying is exactly one pair of parallel sides. So if I go back to our quadrilateral tree, we're going to fit a trapezoid under a new spot, not underneath of a parallelogram. Parallelogram, two pairs of parallel sides, trapezoid exactly one. The specific type of trapezoid that we're going to deal with is called an isosceles trapezoid. That's a different classification than just a trapezoid. Your book doesn't really make that distinction, but I was going to. So bear in mind that we are really focusing on an isosceles trapezoid in this section. So when I talk about an isosceles trapezoid, I'm talking about the legs, which are the non-parallel sides, as being congruent. Your bases are going to be the parallel sides, and then we also have base angles in there as well. But the important part is that the isosceles trapezoid is where your legs would be congruent. In other words, AD would be congruent to BC. Some other properties, if we are dealing with an isosceles trapezoid, then we would know that our base angles are congruent, meaning angle F is congruent to angle J, and angle G is congruent to angle H. Another important part that we would need to know is if I'm dealing with an isosceles triangle, then your diagonals are also congruent. So QS would be congruent to RT. Okay, so we're going to look at those properties in a picture here. So we're going to do all four of these down here at the bottom. So for letter A, we're going to try and find the measure of angle XWZ. And we're dealing with a trapezoid up here. So let's find the measure of angle XWZ. So XWZ, that is this entire angle. That's going to have to come off of this idea with this angle. YZW, they tell me. And if they tell me YZW right here is 45 degrees, then this angle down here should also be 45 degrees. We'll go to the next angle. The next angle would be WXY, which is this angle up here. Kind of hard to pick out, but now these two angles, this 45 here and this angle up here at the top, they're going to add up to 180 degrees. So we're going to subtract 180 from 45, and that's going to get us 135 degrees. I'm going to get rid of my drawings of angles because now we're going to be focusing on our diagonals. So for letter C, we're looking for XZ in here. XZ is this entire diagonal, which is going to come off of these two pieces right here. It tells me WV is 15, and it tells me that VY is 10. So in order to know what XZ is, I need to add 15 and 10 to get me 25. And then for the last one, letter D, it wants just XV. XV is going to be equal to the one here at the top, which was 10. So letter D is also going to be 10.